Hello, welcome to Unit 2, Lesson 6. I'm Professor Blackman. In this lesson, we're going to be talking about graphing more linear equations. So in previous lessons, we've graphed linear equations. In this one, we'll be going a little bit more in depth, where we'll be graphing using a different approach called graphing using intercepts. We'll graph horizontal and vertical lines, and then we're going to be talking about creating equations given parallel and making them parallel or perpendicular based on the situation. Let's go ahead and get started. All right, so in this method, what we're going to do is we are going to find the x and y intercepts. So for x-intercepts, it's always something 0 because it's on the x-axis, so y is 0. And for y-intercepts, it's going to be 0 something because the x-intercept, the x value is always 0 on a y-intercept. So if we plug this in and make y 0, we have 2x equals 6, making x equals 3. For the y-intercept, if we make x 0, we have 3y equals 6, which makes y equal 2 when we divide both sides by 3. And so now we can just graph 3 and 0, 2. And then if we connect those points, we have that line right here. Previously, we would take and solve this and get 3y equals negative 2x plus 6, divide by 3 and get y equals negative 2/3 x plus 2. And so you can see the y-intercept of 2 and the slope of drop 2, run 3 is there. So this is just another option for you to graph using the intercepts. I will tell you that if you are using my math lab and it tells you to graph using intercepts, if you don't have these 2 points on there, it will be marked wrong. Your line can be in the right spot, but if you use like this point and this point somewhere in quadrant 2, it will be marked wrong. It has to be both points that are the intercepts. Let's look at our next example. X-intercept is something 0. Y-intercept is 0 something. So as we plug in the 0, we get 2x equals 6, so x equals 3. Plug in 0 for x, you get negative 3y equals 6, divide by negative 3, and you get y equals negative 2. And so negative 2 and 3, connect those points, and we have our line there. All right, let's look at some more examples. Okay, again, we're going to graph using intercepts. All right, so we have our x-intercept with y being 0, y-intercept with x being 0. Plug in 0, you get x equals 4. Plug in 0 for x, you get 2y equals 4, so y equals 2. Okay, and so we can put those, got my x-intercept of 4, 0 right there, and my y-intercept of 0, 2, and then I will be able to draw my line. All right, so in this one, because it's not in standard form, we want to do a little bit of work. So I'm going to subtract that 3x to put it in standard form because it just makes plugging in so much easier if they're on the same side. Okay, so x-intercept is when y is 0, and y-intercept is when x is 0. And so if we plug in 0 for y, we get negative 3x equals negative 15. Divide both sides by negative 3, and we get x equals 5. For the y-intercept, plug in x, you get 0. So then you have 5y equals negative 15. So y equals negative 3. Plug that negative 3 as your y-intercept. Plug that 5 in as your x-intercept, and connect the points. And there you go. Let's look at some more examples. All right. So again, these are both in standard form, so graphing using intercepts is a great method. So find your x-intercept by making y 0. Find your y-intercept by making x 0. So we plug in 0, and we get 4x equals 12, so x equals 3. Plug in x is 0, you get negative 3y equals 12, so y equals negative 4. My x-intercept is 3. My y-intercept is negative 4. And now I connect my points. Right. Again, in standard form, so graphing using intercepts is a great method. Y-intercept, we make x equals 0. And so when we plug 0 in, we get 5x equals 10. So x equals 2. Plug 0 in for 5x, and you get 2y equals 10. So y equals 5. Y-intercept of 5, x-intercept of 2, and then connect those points. And there you go. All right, let's look at another example. All right, so here we are graphing a horizontal vertical line. And I can tell it's a horizontal or vertical line because it's x equals some number or y equals some number. So x equals 1. Think about where all those values of 1, 0, 1, 1, 1, 2. So no matter what y is, x is always 0. And you get them along this vertical line. So same thing here, make all the values x equals negative 4, and you get this vertical line. Y equals negative 1, so we get this vertical line right here, or horizontal line, and y equals 3/2, that's a decimal approximation of 1.5, and we get this horizontal line there. All right, so those should be very fast to graph as long as you remember what a horizontal and vertical line looks like. Okay, given the equations of two lines, determine whether their graphs are parallel, perpendicular, or neither. So we're trying to determine if these two lines are parallel, perpendicular, or neither. So parallel, one slope equals the second slope. For perpendicular, we have this term of opposite reciprocal. So the slope of one is equal to the negative slope of the other, flipped upside down. Or I've seen that other people will say the slope of one times the slope of the second will equal negative 1. These are two different ways that you can do it. Let's do a couple of examples. So parallel, perpendicular, given slope. So let's say you have 1/2. Slope parallel would be the same. And then perpendicular is the opposite reciprocal. So 1/2 flipped over becomes negative 2. 3/4 would be 3/4 the same, and that's negative 4/3. If you have negative 5 is the same. Flip it, 5/1 becomes 1/5, and negative becomes positive. All right, so let's look at this equation. So if I rewrite that in slope-intercept form, I get y equals, move the 5x over, so move that 3 over, so we get y equals 5x minus 3. And so you can see the slope of the first one is 5. Look at the second one, it's not in slope-intercept form, so we got to put it in that. So negative y equals, move the 3x over, so negative 3x minus 2. and y equals, multiply everything by -1, 3x plus 2. So this slope equals 3. They are clearly not the same, and they are not opposite reciprocals. So these would be an example of neither. All right, so this one's already in slope-intercept form. So we can see that the slope of this one is, the slope of the first one is 3. Divide by 2 everywhere. And we get y equals 3x minus 1. And you can see the slope of the second one is 3. You can see that those are the same. So this is an example of parallel lines. All right, let's look at 2 more examples like this. Okay, so we need to put it in slope-intercept form. So x plus 2y equals 5, and 2x plus 4y equals 8. 2y equals negative x plus 5. Y equals, divide everything by 2, negative 1/2 x plus 5 over 2. So you can see the slope of this one is negative 1/2. So what we need is either this to be negative 1/2 or this to be a positive 2. So we have 4y equals, move the 2 over, so negative 2x plus 8. Divide everything by 4, and you get y equals negative 1/2 x plus 2. You can see that they are the same, so this is an example of parallel lines. All right, looking at our last example, take and write the 2x minus 3y equals 7, and 2y minus 3x equals 10. So we get negative 3y equals, move the 2x over, negative 2x plus 7, divide by negative 3, and we get y equals 2/3 x minus 7/3. And so here we can see that the slope is 2/3. All right, let's do it with the second one. So we have 2y. Move the negative 3x over, it becomes positive 3x plus 10. Divide everything by 2. And we get y equals 3/2x plus 5. So we get a slope of 3/2. And so as you see, this is 2/3 and this is 3/2. They are reciprocals, but they're not opposite reciprocals. If you multiply them together, you get 1, not negative 1. So this would be an example of neither. If either one of these was negative instead of both being positive, then we would say that they are perpendicular. That's all I have for you today. Happy studying.